Yes, students of class 10, this is the fifth video of chapter 2, acid, bases and salt. Now let's review of video 1 to 4. Now in this chapter we have covered classification of chemical substance into acid, bases and salt, how to test acid bases by using acid base indicator, then general properties of acid and bases, strength of acid and bases, role of water in dissociation of acid and bases. Now, effect of dilution on acid and bases. Next, today in this video, we will start with the expression alkalinity or acidity in terms of pH. So this is the topic of this this video. Topic is expression pH terms, pH value. Okay, so pH value help us expressing acidity or alkalinity of any solution. Okay, so pH. So pH value help us to know the acidic, basic or neutral nature of any solution. Clear? Now next let's start with this pH word, right? A Danish biochemist, right, Sorensen, 1999. Okay, he proposed this word pH word. Now in Danish, pH stands for potent dehydrogen. This statement is in Danish language. Now when we take out the meaning of English, it means potential of hydrogen ion. Simple, the power or potential of hydrogen ion concentration. Okay, this is the meaning. So this is the meaning of this pH value. Now see this pH value. Now see, if there is a solution, if the solution concentration of hydrogen ion is equal to concentration of hydroxide ion is equal to 10 to the power minus 7, right, moles per liter. This is a 10 to the power minus 7 at 25 degrees Celsius or 298 Kelvin. This is the one case. And another case, if hydrogen ion and OH ion is equal to Kw. Kw is ionic product of water, So at same temperature, so mathematical value 1 into 10 to the power minus 14. This is fixed value. Now if we know the value OH ion concentration, then automatically the concentration of hydrogen ion will come calculate. So this formula will help in the concentration. If hydrogen OH ion concentration is given, so it is already fixed. So we can calculate the concentration of hydrogen ion. Any one of concentration is given, we can calculate the concentration. Okay. So this is the one case. Now next case is there. See the nature of solution. Yes. First case, if hydrogen ion stands for this. Clear? Hydrogen ion concentration is equal to 10 to the power minus x. So then pH will be x. If hydrogen ion concentration is equal to 10 to the power minus 4, so pH 4. If hydrogen ion concentration is equal to 10 to the power minus 14, pH is equal to 14. So 10 to the power minus 9, pH is equal to 9. So this is expression. Point number 1. Okay. So student, Is clear now? Take one more. If hydrogen ion concentration is given 10 की power 11, then children pH will be 11. Okay, this is clear. I hope you understood this case. Now next, this concentration we are taking in terms of moles per liter. All right. Now what is the definition of pH value according to the Sorensen? Right. The pH may be defined as, right, the magnitude of negative power to which 10 must be raised to express the concentration of hydrogen ion of any solution in moles per liter. So this is a pH value definition. Means pH may be defined as the magnitude of negative power to which 10 must be raised to express the concentration of hydrogen ion concentration of any solution in terms of mole per liter. So this is a definition, very simple. pH, the magnitude of negative power to which 10 must be raised to express the concentration of hydrogen ion. This is a sign of concentration of hydrogen ion. Concentration, to express the concentration of hydrogen ion of any solution in moles per liter. Moles per liter. So this is the definition of pH value. Okay. Now see the next case. If pH, if hydrogen ion and OH ion concentration is same, so this solution will be neutral solution. Okay. Keep this fine. So neutral solution. Now if hydrogen ion is greater than OH ion concentration, so in this case solution will be acidic solution. Okay. If hydrogen ion is less than OH ion concentration, basic solution. So this is the one case. So on the basis of hydrogen ion concentration, we also can predict the nature of solution. It is very simple, children. Hydrogen ion concentration is equal to the OH ion concentration. Case number 1. At room temperature. So neutral solution. And this is a greater acidic solution. If it is hydrogen ion is less than OH ion, basic solution. This is the case. Now next, we have a scale. Okay. So pH scale. Okay. What is pH scale? It is a scale. Okay. So see this, we can represent in 3 ways. A pH scale we can design in 3 ways: on the basis of hydrogen concentration, on the basis of OH ion concentration, on the basis of pH value. So here I am drawing a scale on the basis of pH scale. Okay. So see this. This is a scale. pH on the basis of pH. So this is a 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13 and 14. Okay. This is a, okay, from here it is a neutral solution. We know this is a neutral solution. Exact 7 value is a pH is equal to 7 neutral. Now from this side, acidic character increases. Acidic character of solution increases. Means 0 strong acid. pH 0. Okay. So when we go this side, basic character increases. Basic character of solution increases. from this side. So strong base. Strong base. I am taking example, distilled water, pH 7, distilled water. Okay. If pH is equal to 0, so here I am taking 1 mole H, 1 mole NaOH. Yes. If you will take this, the pH is equal to 0 and acid will be strong acid. The value which is very close to 0, strong acid. So pH is equal to 0, 1 mole sodium hydroxide. pH is equal to 0, this is strong acid. pH C. Now 1 more here, no sorry, this is 1 mole HCl because this is a 1 mole HCl. This is acid, strong acid. Now it is a basic, so 1 mole NaOH, 1 mole sodium hydroxide, pH value 14. So it's so strong base. So it's strong base. This is a neutral and A. So this way we can use the pH scale. Now I am taking one more example to make sure, children. Here I am taking a A, B, C and D. So A has pH value 10, it has 9, 4, it is 0. So my first question here, now which option shows more acidic in nature? Which option shows more acidic in nature here? So as we were, acidic means strong acid. Okay, so solution is there, A solution, B solution, C. So the value very close to 0. The value A, B, here is a C. C is 4. So A data, B, C, 4, D 0. So the value closest to 0, that is a D. So D is a strong acidic, solution. Now maximum value is 10. So A shows strong base. This is base. In comparison to this, A is a strong base. It is a base. It is base. This is this. So children, on the this way we can use the pH scale. On the basis, concluding line is this: on the basis of pH scale, we can predict the acidic or basic or neutral nature of solution. Clear? So this is pH scale. Now, after pH scale, we take up how to measure strength of strong acid and base to measure. So we have one technique, children, very simple. To measure, we have a universal indicator, okay, and pH meter. These two data gives exact value of nature. It gives exact value. Okay, so pH meter and universal indicator. So universal indicator, it is a mixture of number of indicators. Clear? So children, these are the two universal indicators and pH meter. They gives us the strength of acid and bases. Right? Now next, after this topic comes, what is the role of pH in everyday life? Role of pH in everyday life, right? So there's a one example. See, role of pH in everyday life. So first I am taking biological system. Biological system, as we all know, right? pH range 7 to 7.8. This pH range is good for health for plants and animals both, right? So at this level, plants and animals both can survive. Now if the pH goes down or goes above this 7 point above this, goes down, so in this case plants and animals survival will be difficult. Okay, so the aquatic life means survival, aquatic plants or animals, for both survival will be the difficult. So this is the role. So is this way, this pH should be the maintained. Okay, if this is a normal pH range, at this level plant and animals both can survive. Okay, this is a healthy pH value. So pH is a specific for health point. Now next example is the acidity role in pH, role of pH in digestive system. Okay, children, we all know in our stomach there is a natural HCl, hydrochloric acid. What it does, it helps us in digestion, food digestion. Okay, now it is present in by taking more faulty foods, the level of HCl increases, so we feel irritation or pain in our stomach. So these are symptoms of acidity. Clear? So these are symptoms of acidity. To remove acidity, doctors or normally we do use an antacid. Okay, so there is a very simple application. The neutralization reaction we have studied. So salt, okay, acid plus base. This is general concept. Simple principle is applicable here. Neutralization concept. Acid HCl is more axis, base magnesium hydroxide, milk of magnesia, digene syrup or sodium bar, whatever we can take. So it forms salt. So this magnesium hydroxide neutralizes the excess acid present in our stomach. So is this way we relieve from acidity. Okay, so this is a role of digestive system. Now next property is, children, very important, that is the sting. Normally honeybee or red ant, if they stung, what would happen? They release a chemical name is formic acid. The same concept is here. Ant, yellow wasp, whatever, they contains acid. Acid is formic acid. Okay, and they create swelling, pain or irritant pain in our body. Okay, swelling is generated, pain is generated when these red ant or stung. Okay, so children, what we do? So we have a solution. What we do? Neutralization concept. So for this we use a sodium bicarbonate to relieve this. So same concept, neutralization concept. Okay, so in this way we relieve our pain through this technique. Okay, now this is this next very important point. It is very interesting fact. You know, when any person do exercises, yeah, or do a physical labor, they feel pain. Why? So there's a muscular pain. You know, this pain is generated due to the formation of lactic acid. Okay, so this is a reason. So children, so is this way we have covered the role of pH in our daily life. Very important topic we have discussed. So more point is there. We can also study. This is the application of this. Now again recap of this video. Now we have started this video review and then expressing alkalinity or acidity of any solution in terms of pH. Second, strength of any acid bases by using universal indicator. So we have two methods. One is a universal method, second is pH method. Okay, they give an accurate value. Next, role of pH in our daily life or real life explanation we see. Number one, in biological system. Number two, in digestive system. Number two, in sting or chemical war sting. So honeybee, red ant, they bite through. So this is the role of pH in our. Next very important role of pH in, that is a tooth decay. Okay, so tooth decay, one is left. Tooth decay, you know what is the concept? As we all know, tooth is the hardest substance in our body. Teeth, they are made of calcium phosphate. Okay, so when pH value slows down, so what would happen? These teeth starts decaying. Okay, so children, first point, due to if the pH value of the mouth increases, so degradation or tooth decaying is started. Okay, so see this simple concept. In the mouth, acid is present more. When the pH value increases, slow down the pH, acidic environment in the mouth excess, so we use a base and the neutralized salt forms. So base, in terms of base, we use a toothpaste, good quality of toothpaste. We can use neem datun, we can use babul datun. So we have all traditional methods to wash our teeth. The reason behind it, they are basic in nature. All these are weapons to in a toothbrush we use. They are basic in nature. Okay, so this tooth decaying is also very important. The pH value affects the tooth decaying. So normal pH, no decaying. If this pH value rises, tooth decaying, in digestive system, everything is affected. Okay, so children, is this way. So this video we are going to over now. Thank you children. Or this is the teaching aid. Please refer your textbook now. Now in next video we will take up the salt. Okay, acid bases we have covered in these 1 to 5 video. In next video we will take salt. Okay, thank you children.